Hello my dear students, in this video we are going to continue with the two-dimensional arrays. The definition of two-dimensional array says that in order to access each element in an array, it is required to have two subscripts is called as two-dimensional array. The first dimension represent row and the second dimension represent column. Here row can be denoted as the subscript I and column can be denoted as the subscript j. If there are m number of rows and n number of columns, then the total elements required by this two-dimensional array is m into n. M into n also denoted as it is the order of matrix. Now let us take an example. Here you can see first row, second row, third row, and first column, second column, and the third column. So there are total 3 rows and 3 columns. So that is m into n order gives me 3 into 3 is equal to total 9 elements. Now how to represent two-dimensional arrays in memory? There are two methods. The first one is a row major order method and the second one is column major order method. Let us continue with the first one, row major order. In case of row major order, all the elements are inserted in the row fashion, that is in a row order. First all the rows will get filled up, then the columns will get filled up. Here in order to find location of each element, we have to use this formula as location of A of ij. Here A represent array, ij represent row and column. I and j, both of these two are subscripts, is equal to base of array A. Base of array A represent the first block address of the array is base of A plus W. Here W represent the number of words per memory location, and inside the square bracket you can see here we have got n, that is number of columns. Inside the round braces we have written I, that is subscript, minus LB. LB is lower bound, it is always 0, plus J minus LB. J is the column subscript minus LB represent it is a lower bound and it is 0. Here you can see in the example we have A of 0, 0 consisting of 2, A of 0, 1 consisting of minus 2, A of 0, 2 consisting of 3, and so on. Here first rows will get filled up as shown in the second diagram. Here you can see we have got the memory location that starts from 2001, 2002, 2003 and so on, and here you can see elements 2, minus 2, 3, 2, minus 2, 3. So first rows will get filled up that represent first row elements. Next you can see second row elements and the third row element. Second row element consisting of 1, 0, minus 3. Similarly here also you can see 1, 0, minus 3. Third row element consisting of 2, 2, 5. Here also you can see 2, 2 and 5. Now we'll continue with column major order. In column major order we are going to insert elements first column wise. In order to access the location of each element in a column major order, we are going to use this formula. Location of A of ij is equal to base of A plus W. Inside the square bracket, we are going to write I minus LB plus M represent here rows J minus LB, that is lower bound, it is always 0. Now let us take the same example, but all these elements are arranged in a column wise. Here you can see in the second diagram, again the address we have taken same 2001, 2002 and 3 so on. Here you can see 2, 1, 2 means what? First columns will get filled up, that is 2, 1, 2 is filled up, that represent first column elements. So second column elements are, here you can see minus 2, 0, 2, that is minus 2, 0, 2 will be filled up. In the third column elements you can see 3, minus 3, 5. Similarly here also you can see 3, minus 3 and 5. Now it's time to have a programming example how exactly we'll be able to insert the elements in a two-dimensional array using column major order. For that I will take you to my laptop screen. Here we will write single line comment, write a program to read and print the elements in column major order. Let us continue with hash include iostring dot h, then hash include conio dot h, and then we'll write void main, and here curly open brace, and we are going to declare all the variables along with the two-dimensional array A. So let us take A, and here we'll take size 5 and 5 rows and 5 columns. Then let us take I, J, and row as R and column as C. Here we will write cout, enter the order. Now we'll write cin. First we'll take a row, next column, cout. Now we are going to enter the elements. We'll use looping structure for I is equal to 0, I is less than C because it is column major order, and we'll write I plus plus, again take one more iterative statement, j is equal to 0 and j is less than r, that is row, and j plus plus. Here we'll write cin, and in a square bracket we are going to write ij, so that is a of I and j. Now we'll write cout, and we want to now print all these elements. We'll write the matrix in column major order is we'll use for loop I is equal to 0, I is less than r, and semicolon I plus plus, then we'll use curly open brace, inner for loop, and here j is equal to 0, j is less than c column, and j plus plus. Here we'll write cout, that is a of I and j, put semicolon, here we'll write cout and l, then curly closing brace, and here we'll write get ch and put semicolon and then curly closing brace, and here we have to write a of j I. Now let us compile this program. Click on compile. Now it is success, so click on run. Here you can see it is asking enter the order, so I'm going to enter order like 2 rows and 3 columns. Now I'm going to enter the elements 1, 2, 3, then 4, 5, 6. Here you can see the matrix in column major order is 1, 3, 5, 2, 4, 6. Here you can clearly see that the first 2 elements of the first row has become the column, and the remaining elements has become the column. Now let us continue with one example. Consider the array A of order 25 into 4. So here 25 represent m and 4 represent n, that is row and column with base value 2000. So 2000 is the address of the first block and 1 word per memory location. So w represent 1. Find the address of A of 12 3, that is 12th row and the 3rd column in row major order and column major order. So let us see the solution. Here you can see given base of A is equal to 2000, which is already given here, and m is equal to 25, that is number of rows. Next number of columns is equal to 4, which is already given here. LB, that is lower bound, is always 0 because index number starts from 0. Here w is equal to 1. Here you can see it is word per memory location is 1. And next I is equal to, here that is index I is 12 and index j is 3. Next we will write row major order. We will use the formula location of a of ij is equal to base of a plus w, words per memory location n into I minus lb plus j minus lb. Here base of a is 2000 plus w represent 1. Inside the square bracket we will write n represent number of columns, that is 4 and I represent here it is 12 minus 0 plus j represent 3 minus 0, lower bound is always 0. Next we are going to simplify. 12 minus 0 is 12 fours are 48. Here you can see 12 fours are 48. 3 minus 0 is 3. 48 plus 3 is 51. 51 plus 2000 is 2051. Next we will go for column major order. We are going to use this formula location of a of ij is equal to base of a plus w. Inside the square bracket we are going to write I minus lb plus m into j minus lb. Location of a of 12 and 3 is equal to base of a is 2000 plus word length is 1 and I represent 12 minus 0 plus here m represent it is 25. So 25 inside the round braces we are going to write j value 3 minus lower bound is 0. So 12 minus 0 is 12 and 25 3s are, that is 75, because 3 minus 0 is 3. 3 into 25 gives me 75. So here 12 plus 75 is 87. 87 into 1 is 87. 2000 plus 87 gives us 2087. Now let us continue with applications of arrays. The first application is arrays are used to implement other data structures such as heaps, hash tables, queues, stacks and strings, etc. The second application is arrays are used to implement mathematical vectors and matrices. The third application is many databases include one-dimensional arrays whose elements are records. Now advantages of arrays. The first advantage is it is used to represent multiple data items of same type by using only single name. Second one, it can be used to implement other data structures like linked lists, stacks, queues, trees, graphs, etc. The third advantage of array is two-dimensional arrays are used to represent matrices. Next, disadvantages of arrays. The first disadvantage will be we must know in advance that how many elements are to be stored in array. Second disadvantage is array is static structure. It means that array is of fixed size. The memory which is allocated to array cannot be increased or reduced because it is static in nature. It is fixed type. Next, the third one is since array is of fixed size, if we allocate more memory than a requirement, then the memory space will be wasted. If we allocate less memory than a requirement, then it will create problem. The fourth disadvantage is the elements of array are stored in consecutive memory locations. So insertion and deletions are very difficult and time consuming. So this particular method which we have already implemented in the previous video, how to insert an element in an array and how to delete an element from an array. So that task would be difficult. So that is one of the disadvantages of using arrays. That's all in this video. Thank you very much for watching this video. We will see you in the next video.